Okay, hey everyone. In this video, we're going to show you why you might want to consider something like Orchestra instead of a framework like Airflow, particularly if you're setting up a kind of data team from scratch. We're going to quickly run through this architecture, and then we're going to build a pipeline and then show you how you do that in Airflow. So at a very high level, what you're going to want to do when you set up a data architecture is spin up a few components. So the first thing to consider is your kind of data store. In this case, we're going to use BigQuery, but you could use anything like Snowflake. You could go Iceberg and use like S3. Really doesn't matter. The next thing to consider is how you're going to move data into your data warehouse. So for this example, I'm going to use Fivetran. Fivetran is a cloud-hosted tool that just allows you to move data with no code. But as you might have heard, they're also increasing their prices quite a lot. So something we commonly see teams want to do is mix Fivetran with home-built connectors. So with that, I'm going to be writing some Python with a framework called DLT, and I'm going to be running that in Orchestra. The next thing to consider is how you transform data once you're in your data warehouse. So for that, in this example, we're going to use dbt-core, which is a framework for transforming data in data warehouses. And then the final thing is, for this use case, right, let's say you're trying to create a forecast, so aggregate some sales data and forecast that over time. People are going to want to visualize that somehow. So for this, we're just going to use Power BI. And obviously, in terms of all of that, you're going to want to stitch it all together and have a single place to monitor everything so that if there are failures, you can react to it and let stakeholders know so that they don't, come to you and say, hey, this data looks wrong, like what's going on? And that is Orchestra. So, the main benefits of doing that is that, Orchestra is super easy to use. We have a sort of declarative framework where you can edit the code, but we also have a UI. So, literally anybody can use it. Super feature complete, right? It's not just an orchestration platform. We're running transformations. We have a scalable compute engine for Python. And, we're also gathering a lot of other observability type features, which I can show you later. And the benefit of this is that it's super fast to use. You contrast this with, I guess, what we've been sold over the last few years. The first thing is like an Airflow. So in this case, Airflow is doing your orchestration, but it's very hard to work out how to deploy that. It requires the time to learn Docker. Ideally, it will require the time to learn Kubernetes. You'll then have to learn how to deploy that. To have a really robust framework, you're going to want to have multiple environments. So that creates an additional overhead in terms of management. And if any of the words I've just mentioned are kind of foreign to you, you're not alone because they are the domain of people like platform engineers who are quite expensive. In terms of getting like end-to-end visibility of what's going on, anyone that's used a tool like this before knows that the UI leaves a little bit to be desired when it comes to people that are non-technical, which is why we have observability tools like Monte Carlo or catalogs like Atlan. Again, these are kind of like additional costs, additional pieces of complexity that are not necessary with something like an Orchestra. And here on the right, you've just got a super basic example of what an Airflow project might look like. And as you can see, it's pretty complicated. So what do you get with an Airflow approach? Super expensive. It's very hard to maintain. And, unless you're a platform engineer that's been doing this for a long time, it can take you ages to really do anything. So with that said, let's go ahead and check out the code. So this is my environment and it's pretty straightforward. So I've got a DLT file here. And this is a HubSpot pipeline. So I'm not going to go into this in detail. I'll put a link in the description to a video where we do. But all you have to know is that this code is basically moving data from HubSpot to BigQuery. And in order to execute it, all you have to do is call the sort of function on top of it. The next thing to take a look at is our dbt project. So here you can see that I've got a list of different DBT projects. For this one, we're going to want to look at BigQuery, but this is basically just the DBT code that you would have anyway. And then finally, in terms of stitching this all together, we've got a folder for Orchestra, and you can see that this is just YAML. So this is kind of the output, and now we're going to show you how to do that and stitch it all together. Cool. So if you head to the Orchestra UI, you'll probably see something like this, but without any pipelines. And the first thing you need to do is connect up the different parts of your stack. So if I show you my Fivetran connection, you can see Orchestra gives a really easy interface for creating a reusable component that can be used to authorize to Fivetran. In this case, all you do is take the API key, API secret, hit update credentials, and you're good to go. Now, the next thing we're going to want to build is our connection to run Python. So what Orchestra does is it connects to your code base. So in this case, it's this repo called Orchestra Blueprints. It pulls that code at runtime and then executes it. So in order to connect GitHub, in this case, to Orchestra, you just need to head over here, go into settings, developer settings, and provision a fine-grained token. Again, I'm not going to go into this in detail, but I'll drop a link in the description below if anybody wants to do that. So with that token, you can then paste that in to this Python connection block. And all you do is put in where your repository is stored, put in the token value. And then if you've got secrets that you need to pass in at runtime, you can add those here, and you'll see that these are all encrypted too. So in terms of dbt-core, we take a very similar approach. So because our, in this case, we're using a mono repo structure, I've got all of my dbt code in here anyway. So, in the Postgres example, for example, I've got, this Jaffle shop, repo with, lots of bits of SQL in there. So, we can actually use the same token we used before. And this looks basically exactly the same. But there is one difference, which is that, as you know, with dbt-core, you're not throwing in, secrets directly. You typically use profiles.yaml. So you can either paste this in or just drag and drop it from, wherever it's stored. Cool. And then the final component will be Power BI. So because Power BI is something which is hosted in Azure, you need to find your tenant ID, your kind of workspace ID, which is a Power BI thing, and then create what's called a service principal. Essentially, it's like an agent, a role that Orchestra can assume, and that will have what's called a client ID and a client secret, or as they've recently renamed it, an application ID and a client secret. And then this will allow us to do things like refresh Power BI dashboards or, run data flows. So having done that, it's really just a question of stitching the different parts together. And in this case, we're actually going to create a new pipeline, and we're going to back it to Git so I can show you what we're doing. So we'll call this, let's call this end-to-end pipeline. The repository is going to be Orchestra HQ, Orchestra Blueprints. I've got a folder here called Orchestra, which is where I store my pipelines.yaml, and we'll call this end-to-end.yaml. The default branch is the branch where we're running our scheduled pipelines, basically your production branch. So that's just going to be main. And then we're going to kick off with a working branch, which is going to be called dev Hugo. All right, cool. So now that's working, we're going to build our pipeline. So you can throw in a cron trigger. So we're going to say this is going to run every day at 8 in the morning. And then we're going to start adding our different components. So in the case of Fivetran, this would be ingest data from database. You can put in our ID, and this connection is not correct, so we'll throw in the right connection. In parallel, we're going to want to run that Python script that I showed you earlier. So I'm going to go ahead and take this. This will be called run DLT. And because I've got this DLT data pipeline that is in this directory, so in the DLT directory, I want to run this file. So what I'm going to do is I'm going to put DLT here, because I only want to clone this sort of DLT folder. I don't want to clone all of this stuff when Orchestra imports the repo. And then I'm going to say pip install requirements.txt, which is for this specific part of the repo. Pip install requirements.txt, pip install R, sorry. And then I'm going to select this production blueprints connection. And then because we're going to be in the DLT project directory, I can just run Python run DLT pipelines. Cool. So just like that, we've got orchestration and visibility and compute for data ingestion, which is pretty cool. So the next thing we're going to do is execute our dbt code. So here I'm going to go ahead and pick this dbt BigQuery connection. And all we're going to do here is do dbt build. And if we want to monitor things like BigQuery credits, we can do that this way. I say credits, I don't mean credits. I mean the amount of data that's processed, which is related to how much you get billed. Cool. And then finally, with Power BI, I'm going to refresh a data set. And just hold on 1 second while I go and get the dataset ID. Cool. And just like that, we've built an end-to-end pipeline in basically less than 5 minutes. And not only that, but we've got a really, really nice developer workflow, which I'm going to show you now. So I don't want to set up alerting. I'm going to confirm this. And now, if I go to Orchestra Blueprints, go to code, you'll see that we've already got this branch, so we can create a pull request. And you can see the code that's been written by the UI. So I'm going to go ahead and do something which I shouldn't, which is just merge this so that I can illustrate something more to you. So in the terminal, if I say git pull, you'll now see that we have this end-to-end YAML file, which is pretty cool. So if you wanted to start editing this yourself, instead of using the editor, you could do that really easily. Awesome. So now I'm going to go ahead and run this. Okay, cool. So we can see that this is run, and we've got this helpful view where you can see the different steps. So what you will see is this lovely end-to-end DAG. And if we take a look at the Python task, right, we can go in, we can dive in, we can explore the logs, we can see how long this Fivetran sync has taken, and then we can see exactly what's going on in terms of our dbt models. I've got a couple of warnings set up here, and Orchestra is going to press on if we've got warnings. But if these tests had failed, you would have been able to stop and then restart from the point of failure. And then at the very end, we've got this data set that's been refreshed. And I guess the real value add is in all of the metadata that gets collated here. So, if you need to now monitor stuff, you can set up what's called a data product. Cool. And then if you need to now go and dive a little bit deeper, Orchestra sort of gathers all of this metadata so you can identify trends. In this case, there's not a load of stuff going on, right? We've got our 4 tasks here, and here's how long they took. And if you want to really dive into what's going on with dbt, you can see that it's the materializations that are taking a long time. You've got a seed here, got a test here, and obviously no failures, which is pretty cool. We also have this catalog, which gets updated automatically. So here we can see there are a bunch of tables that should be populated. So if we take a look at our events table, we can see the number of queries that are going through on this table, like the number of operations, the query costs, which is super cool. And yeah, this we managed to get set up super quickly. So that's how you do things in Orchestra. I guess to kind of take things back, like what does Airflow look like? What is the alternative? A good place to start would be configuring things. And we'll just quickly go over the first few steps so you can kind of see how long that would take. So the first thing to do is install and make sure you've got your Python version set up properly. This is actually critical because Airflow is tied pretty heavily to Python versions. For anyone who's used managed Airflow in the past, you know that upgrading a Python version and an Airflow version is like a super non-trivial thing. So yeah, first thing to do is make sure your Python version is set up properly with ideally like a different environment. Then there's a little bit more additional configuration. Make sure that your computer knows where Airflow is stored, and then of course it's a question of downloading it. This is very bad from me. There should definitely be a version in here. But yes, you need to install Airflow. Now, if you're running on a Mac, you can just run this. If you're not, then you'll be on Windows or something like that. You're going to have to also install Docker because Airflow doesn't run on Windows. So that's a big thing you need to learn, which I've not mentioned here. And then in order to start getting set up locally, you need to start running all of the different Airflow services. Now, because Orchestra is SaaS, there's like nothing to manage. And, we kind of think there shouldn't be, whereas Airflow is not. So you've got to set up your database. You've got to set up your web server, which is basically the front end. And, you've got to work out how different services, including yourself, can log into things like this. So the first time I did it on Windows, ran into this error, which is kind of painful. And then the final thing to set up is the scheduler. So without the scheduler, nothing's going to run. So already, you've got 3 things to do: a bit of Docker, and then some user provisioning as well. And then hopefully after that, you'll get to the stage where you have the Airflow UI, which looks a little bit like that. And, that's just getting the infrastructure. So that gets you this, but without any pipelines. When it comes to actually writing those pipelines, it's just more and more code. And while there are things like out-of-the-box operators, so here, for example, we're using the bash operator, you could have like a Fivetran operator, which you might not need to edit the code for in the beginning. But as you get to know the API a bit more, and maybe sometimes Fivetran's API changes, and you get an error, you'd probably end up building custom operators, and that's yet more code that you need to be able to write. When it comes to stuff like dbt-core, for probably the last 6 years, the way to run dbt-core was in the bash operator itself. And that is quite limiting because it means that the lineage you get in Airflow doesn't look like this. It looks more like this. So all you can see is, okay, it succeeded, but what happened? Like you don't see that. I think you do get the logs, which is nice, but this is an unnecessary layer of complexity for a layman that's trying to debug something. Obviously, in the last year, there are additional plugins you can use to enhance the visibility into your DBT projects on Airflow, but they require yet more additional configuration. And then, of course, if it comes to aggregating metadata, sort of updating your catalog, this is yet more stuff that you kind of need to build. So, high level, that's the kind of difference between an Orchestra and an Airflow. Hopefully from this you can see how easy it is to get started. I'll drop some links in terms of how you can do that. But yeah, thanks for watching.